Horizontal wells have been popular after 1980 when exploration of natural gas and oil was diverted from the less productive vertical wells. Engineers found a better way of tackling the problem of producing from thin hydrocarbon zones, which is drilling a horizontal well. Horizontal well can be categorized into three types, which are long radius, medium radius and short radius, and each of them have their respective range of radius and build rate, or popularly known as dogleg severity. Drilling a horizontal well has its own advantages, such as water and gas coning can be reduced due to the reduction in drawdown in a given reservoir. Also, production rate can be increased due to the larger exposed area of wellbore to the basin. Moreover, pressure drop and fluid velocities around the wellbore can be reduced, thus leading to the reduction in sand production. Lastly, overall reserves production can be increased due to the larger and more efficient drainage pattern.
There are three basic mechanisms in evaluating pressure transient data from a horizontal well testing. The first step, identify the specific flow regimes in the test data. Evaluation of data from vertical wellbore will generally center on a single flow regime, such as infinite acting radial flow, or we know as MTR, middle time region. However, a pressure transient test in a horizontal well can involve as many as 5 major and distinct regimes that need to be identified. This regime may or may not occur in a given test, or may not be obscured by wellbore storage effects. So we move to the second steps, is to apply the proper analytical and graphical procedures to the data. Each flow regime can be modeled by an equation that can be used to estimate important reservoir properties. At best, only groups of analytical parameters can be determined directly from equation. It is imperative that the proper analytical and graphical procedures be applied to the data. As many cases, when solving for specific parameters, the application of these analytical expressions may be involve a complex iterative procedure. The last step is to evaluate uniqueness and sensitivity. Experience indicates that results of horizontal well test analysis are seldom unique. So, it is important that uniqueness and sensitivity of the results to assumed properties be evaluated. Simulation of the test using properties that have been determined from the test can confirm that at least the analysis is consistent with the test data. A simulator can also be determined whether a set of formation properties can also lead to a feed of the data.
In petroleum industry, a well test is somehow like the executions of a set of planned data acquisition activities to broaden the knowledge and understanding of hydrocarbon properties and the characteristic of the underground reservoir where hydrocarbons are trapped. So basically, in drilling operation, we kind of deal in two types of well, which is the horizontal well and the vertical well. But still, we have to execute the well test analysis in each well. So basically, in horizontal well testing, the function is, of course, to evaluate the pressure unsteady data that we trying to find in horizontal well in order to have the further procedure in terms of our production in the future. So basically, the difference between the vertical well and the horizontal well is actually in terms of the productivity estimation, because we know that in horizontal well it's more challenging, it's more difficult because the horizontal well is more to like subject to more uncertainty compared to in vertical well. But we know that in vertical well, the variable that we use is actually in terms of average permeability, the net vertical thickness, M skin, and so many more. However, in horizontal well, it needs more than that, not just like the permeability, you see the one that I mentioned just now, it's not just that. It needs more detail because we know that in horizontal well it's kind of very challenging in terms of executing this kind of test data. So basically, when I mentioned just now in terms of requiring more detail, is actually in terms of our horizontal dimension of the reservoir. When we talk about horizontal dimensions of the reservoir, we are talking about the size of the reservoir, the region that we are trying to focus, so that we can gain more information, so that we can more confident in executing our production operation. But however, of course, in gaining those kind of information, which is the horizontal dimension, we have to know our horizontal well bore as well. So basically, in horizontal well, it's much more complicated compared to vertical well.
Testing horizontal wells is still challenging in terms of measurements and interpretations. The field experience conducted for the previous years indicates that interpreting tests from horizontal wells is much more difficult than for vertical wells. However, well test analysis in horizontal wells can provide data such as initial reservoir pressure, permeability thickness, skin factor, well bore perforated length, distance of horizontal well bore to the bottom of formation, permeability and effective permeability. Horizontal layering is most applicable in formation with natural vertical fractures, thin layered reservoir, old reservoirs that are no longer having adequate drive mechanism, producing reservoirs with extremely high deep angles, exploration and development of inaccessible locations, and areas where environmental concerns minimize the number of surface locations. The industry has developed latest technology capable of performing logging the horizontal open hole leg, inflate and isolate stages in order to identify the oil-water contacts and select the optimum hole intervals for simulation.
Alright, now we're talking about the challenges in the horizontal well testing, right? So basically the first one is heavy oil environment. Why? Because the ESP, electrical submersible pump, it needs to be integrated with the DST, drill stem tests. Now, this one, the fluid handling with conventional equipment, it's very complex, because it is due to the pressure drop and extra heat requirements. And then basically, other more is that viscous oil, the gas separation is not that good because the density of the oil and the density of the water is not much different. So the viscous fluid leads to higher retention time, which by means we will cost more time in the horizontal well testing. Now, the second challenge in horizontal well testing is continuous development of the channel. So what do you mean by this one? It is because cement is used to displace the solids, the muds in the annulus, but because of gravity, they drag it down, they drag the cement down. So basically, cement is left downwards; it's not stay at its place, and then the gravity causes continuous channels to develop on the top side of the liner because of fluid separation, right? And then at the bottom side is a non-displaced cuttings. So it's basically makes the hollow, the area to do the horizontal well testings become smaller and it's harder. Now the third one is the perforation of the well. Most oil companies have been reluctant to cement and perforated the entire length of the horizontal well. But in the well testing, it's actually we need just a little of this perforation. We don't need it much. So this one, they basically need to reduce their perforation intervals to just a little ones between them. So small perforation can actually, the large perforation can actually becomes a difficulty to the horizontal well testing. Alright, the fourth one is the limitation of the equipment's deviation. You see, the dogleg severity DLS has become more steeper, which is more than 8 degrees per 100 feet. So the wireline conveyed gun, its deviation limit is around 75 degrees. So basically, if it is beyond that level, beyond that limit, it needs to be pushed down by TCP, tubing, conveyed, perforating, or CT, coiled tubing. So these two can actually be done. But the TCP, it is expensive, while the coiled tubing is much less expensive. So basically it's the good a good option. But the thing is, it's gonna cost you a lot more time. Alright, next one. The useful and accuracy of the data information is not very accurate, especially for the vertically of the reservoir. So in the last few years, the main thing we learned is that we are not testing them correctly. Why? Because the problem is we can't get the useful information within usually the typical 24-hour period, alright? And then perhaps it's usually take weeks long, or maybe more days, just not in one day, alright? Now, we don't know outside limit of the envelope, which by means, if it goes vertically, we can't know the permeability or even the effective permeability, because we really need to know that, because we want to produce a lot more of the oil. And then this leaves the build-up as the best option compared to drawdown test. Why? Because build-up, it is not because of shut-in, it is after the shut-in. And then this one, we can't identify all the flow regimes, because producing wells interfere with the transient testing, alright, which precludes the testing. Alright, last but not least is the identification of the early radial flow. Of paramount importance in planning a reservoir horizontal well testing is an attempt to identify early radial flow. Why? It requires a downhole shut-in. You see, this downhole shut-in is actually not good. Because why not good? Because it will take you a lot of time, more time. But it is really good in the hope for minimizing the wellbore storage effect. Because we really want to minimize the wellbore storage effect. Why we want to it? Well, we want to, because with wellbore storage effect, it's gonna take a lot of time and it's gonna go with a lot more uncertainty. So that will be the challenge.
In a nutshell, horizontal well testing requires a lot of technical expertise to interpret and analyze the data. The problems in horizontal well testing are complex. Thus, the results from the well test analysis may be inconclusive. In addition, the more significant wellbore storage effect prevents the determination of early time data on pressure change, such as vertical permeability, and also middle time and late time data require several hours before they appear in the transient analysis. In order to overcome the problems of horizontal well testing, some modifications should be exercised, such as to run tests in the pilot hole first before drilling the horizontal section. This is because from test result from vertical section, we can estimate the vertical and horizontal permeability using modern wireline test tools. Next, a good directional drilling survey can frequently provide an adequate estimate of standoff. A production log flow survey conducted with coiled tubing can determine what part of the wellbore is actually producing, therefore help provide an estimate of effective productive length. Wells in developed reservoir should be flowed long enough to bring pressures along the wellbore to equilibrium, thus minimizing cross flow. And for high rate wells, continuous borehole pressure and flow rate measurements acquired during production can be used to interpret the pressure drawdown transient response. And if the downhole rates are not measured, then the build-up test should be conducted with downhole shut-in to minimize wellbore storage distortion of test data.